After this talk, you will know how to help people with visual impairments to understand GIF contents on their phone. Using Galley, an automated GIF annotation system for visually impaired users. Hi everyone, I'm Mingrui Zhang from the University of Washington, and I'm presenting this work in collaboration with Mingyuan Zhong and my advisor Jacob Wobbrock. So this talk is about GIFs. We love GIFs and we use it everywhere on the internet. Famous memes are made in GIF. We send stickers in GIF to chat with others. And sometimes we use it for fun moments. But for people with visual impairments, GIFs are almost unavailable for them because most of the GIFs are unlabeled. When you are using a screen reader to focus on a GIF, usually it will say something like unlabeled. And here is an example in Twitter.
Your message, June 20th, 21, attached GIF from you.
So it only say attached GIF from you without any annotation provided. And some of you might say, wait a minute, why can't they generate captions automatically? With the advancement in computer vision algorithms, screen readers can now generate auto descriptions for static image. Well, for GIF, they are far more complex than a static picture because they are composed of multiple pictures together. This is when I used Google Cloud Vision system trying to generate a description of this GIF, a cat nodding its head. But the description was completely wrong. There are many challenges to describe a GIF automatically. The first one is the dynamic scene. Actually, a GIF can include multiple scenes from different sources. It can be hard for the algorithm to connect them logically. Another challenge is that many GIFs include characters or cartoons from clips, like movie clips. And to make an understandable description, the algorithm needs to know about the background information of those clips. Lastly, the most difficult part is a nuanced emotion expressed in many GIFs. For example, here the man is nodding and saying right, but he looks reluctant. For now, only humans who are aware of those cultural background or the meme backgrounds can decipher those subtle expressions. So given those challenges, how can we design a system that generates annotations for GIFs? The answer is to use humans. Well, a more realistic solution is to combine the power of machine learning and crowdsourcing. We could use computer vision to provide a fast but rough descriptions, and then let the crowd power to improve the description quality. And this is what Galley does. There's an 11 in the name Galley because accessibility is 11 words plus ANY. And here's an overview of the system. It has 3 components. A mobile client that is able to recognize GIF on the screen using heuristics from app-specific UI structures, and the user could double-tap the GIF to request annotations. The requested GIF is then sent to the server, and the server will perform visual similarity comparison using the perceptual hash function. If there's no similar GIF found, it will return an automatically generated description using the computer vision algorithm on a random frame. The GIF will also be posted on the annotation website. Anyone can go to the website to provide their annotations. Once the GIF is annotated, the human annotation will be returned if it's requested a second time. So here is a demo of requesting annotation with an automatic description returned.
Your message, get GIF description button. Last GIF, automatically generated caption is diagram. Best guess is chill GIF. The labels are cartoon and azure and gesture.
And here is a manually labeled GIF annotated from our website.
Get GIF description button out of list. Last GIF, a brown dog wearing a small hat sits on a chair inside a burning room filled with fire and smoke. It stares blankly ahead and then picks up a mug from the table in front of them and says, "This is fine." They smile and look at the mug while the room continues to burn. Usage scenarios. It can be used by people going through a difficult situation but act as if it's normal enough.
Okay, it's too long, so I didn't play it fully. but you can get the sense that this description is very detailed and explain the GIF well. One challenging issue for crowdsourcing annotation is to gain high-quality annotation. To ensure high-quality annotation, we need to design a good instruction task. We explored 3 instruction styles: freeform, structured, and semi-structured. For freeform, it's the same as a base instruction, that the crowd workers will freely compose their annotations with the instruction. For structured, we derive several important points for a GIF annotation and let the crowd workers fill each point with a structured answer. And we then concatenate those answers. And some of the questions include what are the characters, what are the activities in the GIF, if there is any background information, is there any text. And the semi-structured task design actually combines the structured and the freeform, but still let the annotators freely compose their annotation. We tested these 3 task designs with some of the example GIFs on Mechanical Turk platform, and then we evaluate the annotations with sighted users on the same platform, as well as blind or low vision users via remote meetings. Here is the feedback from sighted users. The semi-structured annotations gained best scores in each category. And here is the evaluation from GA11y users. They also preferred annotations from the semi-structured tasks. They mentioned that the structured annotation sounds like robot. So we just deploy those semi-structured task design in our annotation website. After having the system, we invited 12 GA11y users from both China and the US to install Galley on their phone, the client, and let them use for 3 days. During the time, we act as crowd annotator to provide annotations for their requests. And they use the system quite often. Over the 3 days, they requested for over 500 GIF annotations. Although the machine-generated annotations was not accurate, participants appreciated how fast the result can be proceeded. Here is an example of the human annotation pieces. Participants mentioned they were very accurate and very detailed, but some of the participants complained about the length of the annotation. They were too long, and hoping that Galley can provide a shorter version of those annotations. Sometimes machine alone cannot solve the problem, and especially when it includes cultural or subjective content like GIFs. So we need to make use of both machine and human power to create adaptive and inclusive interfaces. As one of our participants said, it was important to speak the language others speak. For more technical and evaluation details, please refer to our paper. We also open source the Galley system and welcome everyone to extend the idea to other applications. Thank you.